Okay, guys, so we're going to finish off our functional group chart, and we got to go to this last column. So we're going to have our functional groups that contain a carbonyl. So a carbonyl is an important name that we need to remember, and that just means it's a carbon double bonded to an oxygen. And then what is on either side of that carbon, so we already have 2 bonds to carbon, we need 2 more. Whatever are on either side is what dictates the name of that functional group. So if you have a carbonyl next to a hydrogen or a carbon, those have specific names. The first one we'll talk about is an aldehyde, carbonyl next to at least 1 hydrogen. So in this case, we're going to, we'll write this first. We're going to have our carbonyl, and then on the end, we're going to have at least 1 hydrogen. So I'm going to write hydrogen here, and then I'll put my R group on the other side. So in this case, R can equal hydrogen or carbon or hydrogen. It's most often going to be carbon, but if you have a hydrogen on both sides, that's still called an aldehyde. Okay, so an example, let's think of one that I've used recently. An example is such as this molecule here. I just used this recently. I don't have any exciting examples of aldehydes at the moment. But you see that we have a carbon on that side. We can also, just for example, we can have our formaldehyde is the actual name of it, but we can have an aldehyde with a hydrogen on either side. I am going to show you that there are 2 different ways that people draw aldehydes. You've seen me so far draw out that hydrogen every single time and write that H to be explicitly clear that there is a hydrogen there. However, if you remember our skeletal drawing rules, any bonds left out on carbons are assumed to be bonds to hydrogen. So we can also draw this aldehyde just like this. Let's go ahead and put the rest of the group, the R group on. We can draw it just like this, and those are the same thing. We do not explicitly have to draw that hydrogen. You will find that I always will draw it because I don't know, I feel like this carbonyl is just like naked or something. Maybe that's just me, but I like drawing it there so that I know for a fact I'm not like just forgetting something or didn't just like stop drawing the molecule halfway through. Okay, so the next one is called a ketone. Wrong color. It's called a ketone. It's a carbonyl next to 2 carbons. So we have our carbonyl in the middle, and then we're going to have an R group on either side. In this case, R equals carbon. So it says carbonyl next to 2 carbons, so R has to be a carbon for this. So let's look back and look at an example of one of these. Maybe we can have a carbonyl and then have those carbons connect into a ring. That is one that I've used recently, so that's really why I drew it for you. An interesting one, technically this is a slightly different functional group name, but may as well show you because I think it's fun. These are 2 ketones next to each other. And then if you have just a methyl group on each side, so I'll write CH3 just to be specific. This molecule here is actually the molecule that they use as movie theater butter. So it tastes like butter and it smells like butter, but it's that like fake orangey butter stuff. This kind of, when I learned this, it kind of ruined me, to be honest, on fake butter. But it's just the simple diketone molecule here that is responsible for the fake butter taste. I used this molecule in research back 4 or 5 years ago, and it's very, very strong when it's pure. So it's a little hard to get out of your nose. So just as a little caveat, this is not specifically just a ketone. This has a little bit of a more special name, but you can see that you have your ketone in there because you have your carbonyl with a carbon on either side. It just so happens that one of those other carbons is another carbonyl. Okay, and our last three are going to be carbonyls next to heteroatoms. So our first one is called a carboxylic acid. I'm going to warn you now, I often misspell carboxylic, and I apologize when I do that. This is a carbonyl next to an alcohol, next to an OH. So it looks like this, carbonyl OH, and then you have your R group. An example of this, this is not really a historic example, this is just an alley example. This molecule here, one of my coworkers was making and accidentally spilled it on the area that I work in. And carboxylic acids are kind of smelly molecules. To me, they kind of smell like trash, like sugars. When they decompose, they typically make carboxylic acids, and it just smells awful in my opinion. But this is a particularly volatile, so it's a molecule that turns into a gas fairly easily. And so for days, it smelled like trash around where I worked. It was great again. So these are also smelly molecules, just for your fun facts of the day. Continuing on, we have esters. This is a carbonyl next to an alkoxy group. So this is just OR. So for example, our general structure is going to be our carbonyl, O, and then an R group. So this group is typically in the middle of a molecule. So we have an R group on either side. An example of one, let's have our general structure, and then we have this, for example. We have a cyclohexane as one R group and then just an ethyl group on the other side. This is a ester as well. So these, it's kind of funny because I mentioned that carboxylic acids smell really bad, whereas esters, just adding a carbon instead of a hydrogen there, actually are what smells really good. So esters are the molecules that we use as perfumes. They're also like candles and everything. Those have esters inside them, and that's what makes them smell good. For example, there is a molecule that's an ester that's a banana that we could make in the lab. If we were in person, I would make it for you guys and let you guys smell it and everything, but can't do that right now. But grab a banana and know that the smell responsible for a banana is an ester. So just adding that carbon chain goes from smelly to not smelly. Okay, so our last one is going to be an amide. You'll notice in some videos they call it they pronounce it slightly different. It's an amide or amide. Those are different pronunciations based off of British English. So in England, they will call it, they will pronounce an amide slightly differently. But how we will pronounce it for this course is amide. This is going to be a carbonyl next to an amine. So carbonyl next to a nitrogen. So the general scheme for this is carbonyl, nitrogen, and now nitrogen has 3 bonds that it likes. Therefore, we need groups on all sides. So we have 3 different R groups in an amide. For example, a molecule I recently made and published a paper surrounding is this molecule here. Oops, forgot a couple bonds. There we go. This molecule here. So this particular molecule also has a aromatic ring or aromatic group on it. Oh, excuse me. There we go. So this is just a molecule that I was working on for my reaction. Nothing super exciting about it, but an amide could have a variety of different shapes or forms. We have 3 R groups, so those R groups could connect to each other. I forgot to mention, R in all of these cases is carbon. So when I say R is carbon, that means that that immediate atom at that R group has to be a carbon. But after that, it can change to whatever, just to clarify. So off of this nitrogen, there's carbons. Actually, so this one over the amide is a little bit weird because this R has to be carbon. Maybe we'll do 2 different colors. This R has to be a carbon. However, these 2 R's could be carbon or hydrogen. As you see with amines, the R groups can be carbons or hydrogens. So on the amides, off of the nitrogen, it's also carbon or hydrogen, which is a little bit tricky. Okay, so this is all of our functional groups that we'll be learning for this class. Just so you guys know, I do not expect you to fully memorize these if you don't choose to. This entire class is completely open note. So you can access these notes if you need to on our quizzes or exams and everything. However, as we go forward in this course, we're going to be using these functional groups over and over and over and over and over again. And so learning them and understanding their names, it makes it easier so that as you're listening to lecture and I'm like, this amine here, you know what I'm talking about. You don't have to go find your notes again and flip through them and figure out that I'm talking about a nitrogen with all single bonds around it. So you don't have to necessarily memorize these. However, I do think that it would be a great idea for you guys to do that and go ahead and start making flashcards for these and everything. You'll see on our next video, we'll be doing some practice with these. So a really fun way to practice these is to just find fun molecules. Find molecules, Google search the molecule of maybe a drug that you're taking, or that sounds kind of bad, but like a pharmaceutical medicine that you're taking, or ibuprofen, Advil. Google molecules and then identify which functional groups are in them. And that's what we will be doing with our next practice activity. So I will see you guys in that video.